Question 2 is about batteries and charging. The first diagram shows as a mobile phone being charged by a portable power source, so some sort of power bank. Obviously there's a battery inside the mobile phone, and there's also a larger battery inside the power bank. Why does the battery in the phone need recharging first of all? Well, batteries store chemical energy, so once that store of chemical energy has been reduced, you're going to need to recharge it. So it is this one. So remember, chemical energy, battery. So we have a calculation question next. The power source provides a current of 1.86 amps at a potential difference of 3.9 volts. Calculate the power of the source using the equation power equals potential difference times current. So power equals potential difference multiplied by current, so P equals V times I. The potential difference was 3.90, so we'll substitute that in. The current was 1.86, and that gives our result as 7.254. The unit will be watts. If you look at our question, that's 3 significant figures, that's 3 significant figures, so we want to round this value to 3 significant figures as well. So I'm going to write 7.25, and the units will be watts. Either a capital W or watts will be fine. A lowercase w will not get you the mark. So student needs a new power source, so we're going to have to compare and contrast these, so we need to figure out which one's going to be best. So 3 different size power sources. Here is the data about it. So the compact one only gives you 1 charge, and it's got a mass of 100 grams. Large one, 5 charges, mass of 200 grams. High capacity one, 10 charges for 600 grams. So we'll compare the large versus compact first. And the first point is that, well, it has 5 times more charge, or it can give you 5 times as many charges for only double the weight, double the mass, sorry. So the mass is 200, so it's double the mass, but again you can charge it up 5 times more. So those are your 2 marking points for the first one. Next, for your large versus high capacity, it contains half the number of charges, but if you look at its mass, if you compare 200 to 600, it's a third of the mass. So for a third of the mass of the high capacity. So the charge to mass ratio is much better. So hence you would go for the large one either side. So you would choose your large one.